Welcome those who have logged in. We're going to wait 2 or 3, maybe just a few minutes for others to log in. This is Gary Kokens. I'll be the moderator. I'll introduce our speaker, Liam Barbary. So stay tuned. Again, those for you who just logged in, we're going to wait a couple minutes for a few more to log in. We'll get going fairly soon. This is the moderator, Gary Kokens. This is Gary Kokens. I'll repeat, we're going to wait probably 3 or 4 minutes for others to log in, so be patient. This is Gary Kokens, the moderator. So this is Gary Kokens again. The moderator, will start in about 2 minutes, 5 minutes after the hour, USA time. Okay, let's get starting. Well, welcome. This is Gary Kokens. I am the moderator for the Society of Cost Engineers webinar. In a few minutes, I'll introduce our speaker, Liam Barbary. This is being recorded. If you have questions, Liam's email will be at the very last slide. You can also put them in the chat box. I'll try to look for them, and we'll get going here. Hang on. My intro of Liam. Oh, and regarding the Society of Cost Engineers, if you are not a member, please go to our website, the Society of Cost Engineers. A lot of good material there and the tabs, and consider joining. So let me introduce, the topic today is going to be on basically broadly carbon footprint reporting, climate change and the like. Seems to be accelerating in terms of media and the press, ESG, environmental society and governance, talk about it. So let me introduce Liam. Liam has over 18 years in the flexible packaging industry. He has worked for Amcor Flexibles, managing the UK dairy and meat market, and subsequently Südpack as their global key account director. Liam has a vast experience in packaging sales to key accounts. In 2011, Liam, along with two business partners, set up Benchmark Consulting and developed the world's first web-based estimating and should-cost modeling tool. So Liam, hold on one second. I want to give Liam's email address. Oh, there it is. It is liam.barbary, Liam Barbary, at benchmark-consulting.co.uk. So you can directly communicate with him afterwards. Liam, take over.
Thank you very much, Gary. Topic of today's discussion should probably make a nod to some of the sponsors of the Society of Cost Engineers in today's session. Benchmark's logos at the top in the middle there. Today's session then, we talked about environmental social goals in our last webinar that we presented for the Society of Cost Engineers. Jerry had asked us today to talk about how to drive continuous improvement in cost and carbon. Sometimes those two things go against each other. So what I'm going to go through today is some of the things that you would have seen in the last webinar in terms of some of the definitions. And I'm not going to spend a lot of time on them. You can use the presentation as almost like a reference document. But it is important to understand some of those definitions, because particularly for life cycle assessment and carbon footprint modeling, understanding where the data is coming from, how you use that data is quite important. I think for Society of Cost Engineers, I think people watching this video and attending this webinar probably more comfortable with cost modeling itself. So what we're doing is we're saying, right, outside of cost and carbon modeling, how do you go about driving continuous improvement, and how can you use cost modeling to support that and carbon footprint modeling? So let's get into it. So the first slide here, we're just going to cover off some of those definitions that we talked about last time. LCA, life cycle assessment. CO2e is carbon footprint. The E at the end is equivalence. So all impacts, say all, a lot of the impacts to our planet can be in an equivalent way brought back to a CO2 number. So they call it CO2e. It might not necessarily be carbon directly itself, but it will be other things that can be measured in terms of carbon. The really nice thing about that unit of measure is that we end up with one single number that we can benchmark one activity against another. There's something there to be said for circular economy. And then something that we all hear is net zero. Now, continuous improvement and the continuous improvement process, cost reductions included, the net zero approach also falls into this thought process and methodology. So much to say that if you have a certain carbon footprint today, it stands to reason in the next 5, 10, 15 or 20 years, you might want to get to a net zero position. To achieve that is exactly the same as a cost out, value engineering, continuous improvement style project, albeit the focus there is carbon footprint rather than cost. So there's a quick definition of net zero there. Again, I'm not going to go through these in a huge amount of detail. It was covered in the last webinar. If you want to go to that link and you can have a look at that. But you'll also have access to this presentation. And again, you can use it as a sort of reference point. Now, this is an important point, greenwashing. one of the main reasons for going over some of these definitions is because of greenwashing. There is a slide in a minute where I'm going to remind anybody watching this video that watched the last one as well, that greenwashing, at least in Europe, is becoming a pretty hot topic, actually. Not that it was frowned upon before, and it is still frowned upon, of course, but there are legislation and laws that go against greenwashing. So if you are making claims and you are preparing reports that are connected to life cycle assessment, carbon footprint modeling, be absolutely clear that you know where your data's come from and how you're processing that data to drive that number that potentially could make it into the public domain. Because particularly in Europe, once published, you can be held liable for those numbers if they're not true and honest. Another part of this, not necessarily for today's conversation, but a useful definition nonetheless, is understanding what scope 1, 2, and 3 are for carbon emissions. So just be clear again, if you are doing life cycle assessment, that if you're taking scope 2 data from a scope 2 database and then scope 3 data from a scope 3 database, you can't mix and match your data in that way when you're life cycle assessing. Again, covered in a lot more detail in the last video, but yeah, quite useful for you to have understood some of those definitions. Some of the external data sources, again, I think these are really useful reference slides, so I have included those. EcoInvent is a global leader in carbon footprint data. If you're building a life cycle assessment, you'd struggle to do it without EcoInvent if you wanted to do it in a truly consistent way. For energy data, International Energy Agency, and there are 1 or 2 other sources of information, particularly for North America, that are also very useful. But if you are comparing different regions within your business, the International Energy Agency is fantastic because they do cover so many countries. So at least then you can pick your energy data and the carbon impact from that energy from a consistent source. So why carry out a life cycle assessment? Is exactly the same reason why you might carry out a cost assessment as well. Some of the things that you need to do, and this is covered later on in the presentation, some of these best practice principles as to how to run a life cycle assessment also go on with cost modeling. And actually, it's quite interesting, the same group of people that are qualified life cycle assessors maybe haven't been in the finance or commercial area, where a lot of people that are members of the Society of Cost Engineers would have been. Actually, a lot of those principles aren't carried across. So all we're saying here is that if you do choose to run a life cycle assessment, that part of your continuous improvement journey does include this life cycle assessment side, use all of those principles that you should already be aware of as good cost engineers, that you need to set out your goals and define the system, your data collection, your modeling, and your impact assessment and how you do that. Very, very similar to cost modeling, albeit the goal there is a focus on carbon footprint. And again, some of this will come to its importance. And this is where, we talk about this slide and how to eliminate greenwashing. The reason for representing, and it is repeating some of the things that we had gone through in a lot more detail in the last webinar, is mainly for this slide, mainly for these considerations. You need to be very, very careful of the numbers that you put out in the market. There is a UK green claims code, very difficult to say, and the Netherlands also has something as well, and I know France are publishing something within the next few months also. And this is legislation. This isn't just guidance. This is if you make a claim, you put something in the public domain. Obviously, you're looking potentially to brand build off the back end of that. So then that is in a certain way commercially benefiting the business. You can be held to task on that. So cost modeling. This is the Society of Cost Engineers. I'm sure you've got good routines and you've got a good understanding for what to do there. If you choose to go down and use those skills that you've obtained to go down the life cycle assessment route, you do need to be very clear on where your data sources are coming from, how auditable they are, and they can really stand up to scrutiny. So let's try and get into the key topic of today. So continuous improvement. How do you manage a continuous improvement project, be that for cost or carbon? Okay, so what you've got on the left-hand side here, I've taken some graphs from a recent study that we did. It was a big paper versus plastic assessment that we did on a variety of different pack formats. And actually, one of the pack formats I've picked out for you, you can see here. So this is fresh pack salad. And you can see the picture at the top here. You've got the plastic solution, which I think we're all very familiar with. And underneath it is a decision for a particular French brand that decided to go down a paper route. And actually, if you're looking at it on a big enough screen, you can see here that yellow circle in the pack there is actually promoting that this is 95% paper in the specification. So the crazy thing here is that, you know, they've done this to try, you know, it's a fresh salad pack. They want to promote the fact that it's environmentally friendly, and you can imagine the story that's played out within this particular company. They would have sat round and said, we need to do something that's more sustainable. Ideally, we need to get rid of anything that looks like plastic, because, you know, that seems to be a bad thing and paper is the preferred option. And the way they've run their project brief is to say, right, so we need to run a project brief that is entirely for the consumer perception. And that, when you look at the numbers, I can only assume was their only agenda in this project. Because what you've also got on the left-hand side here is the cost breakdown and the carbon footprint breakdown. So what I can tell you here is that from a cost perspective, it's about twice as expensive to go for a polyethylene coated paper versus the standard plastic solution. So much to say it's a lot more expensive. Okay, the production processes are both very similar. You have to extrude the plastic, print, laser and slit the plastic material. For the paper, you have to produce the paper and then print, laser and slit the paper to make sure that you can modify the barrier to allow that salad to last the 48 hours that it needs to. So first point is it's more expensive. That's not necessarily the end of the world. So, you know, it's not uncommon. It's not uncommon, it's not so often, but it does happen that a more expensive packaging solution will be opted for in order to, you know, drive brand differentiation or anything else, or extended shelf life, whatever the case may be. And it might make sense commercially if the shelf life is extended, if that was the case, that you'd pay extra money for that packaging because you're getting a downstream benefit. So you say, okay, they've moved to this paper solution because they want to move to something that is more environmentally friendly. So we then also did the carbon footprint assessment on this as well. And as you can see here, well, even that you are moving from plastic to paper, the paper solution is a lot heavier in terms of its specific gravity, its weight, so its grams per square meter is a lot more. You're talking about a 20 micron OPP that will be the solution at the top there, which will be you know, something like 18, 19 grams worth per square meter, where the paper needed to produce something like the paper style pack is somewhere between 60 to 80 grams worth of paper. So it's a lot heavier in terms of its specific gravity. Now, obviously with that weight, there's more material, it will drive a higher carbon footprint. We haven't included the end of life in this analysis, but what I can tell you is if the end of life goes into this as well, yeah, unfortunately, we've only got 70% recycling rates on paper in Europe on average. So that 30% that makes it into the landfill sites is actually very harmful to the environment. So all in all, here's a good example of a project which unfortunately wasn't managed as well as it could have been. They've managed to drive more carbon and more cost into their supply chain as a result of changing packs from the traditional plastic to a paper solution. So what I want to do with the next few slides really is talk about where did it go wrong, and what could they have done differently, and what would, say, an ivory tower or a best practice approach be if they were to do that. So the first point that you can see on this slide here is, first of all, start with a project brief. What do we want to achieve? Begin with the end in mind. You know, it's particularly important for a life cycle assessment. Just the same as cost assessments, with a life cycle assessment, if you don't begin with the end in mind, which is to say we want to reduce the carbon footprint and why do we want to do this, then you could end up developing and having activities and mini projects running through the business that aren't serving to an end goal. So it's really important to have a laser focused goal at the beginning that will achieve then drive the activities to drive that result at the end. And one of the key things here is not having a clear brief at the beginning to outline the project is often one of the biggest problems with CI projects, generally speaking. And I think that's a lot easier to understand when we get into operational projects. The second part is data gather. Now, again, Society of Cost Engineers, I think most people that would be attracted to be part of our society are going to be data lovers. I don't need to sit here and preach to the converted that you guys understand the importance of data quality, data consistency, how that data is gathered, and just don't accept the numbers. In an operational standpoint, you know, we need to be careful that data gathered from an operations facility in one factory is gathered exactly the same way with the same definitions in another factory. And again, we can talk about that a bit later. So the data gather side. Then we get to the project scope. So once we've understood the data, we've understood the scale of the problem. So if I wanted to reduce my carbon footprint, then I would want to understand everything that goes into generating that overall carbon footprint. And then how do I go around driving that down? So we need to then look at, right, where are the areas we need to focus? We need to start scoping the project to say, right, now we know what we want to achieve. We've got all the data in front of us to say where the potential issues are. Now we need to start scoping the project to say, what are we going to do to get to whatever defined goal that we've come up with? And the final stage is to then run the analysis. You know, once we've scoped out some ideas, let's run some analysis, find out if we were to conduct that work, and let's assume a delta to say, well, if we deliver where we expect or we over deliver, where are we hoping the net result of these activities to come? Are we going to hit our goal? And we can talk about what that looks like. So I'm going to focus one by one on each one of these different slides, these different areas. So let's talk first of all about the project brief. Begin with the end in mind. So as a senior leadership team, you need to take considerable amount of time to consider the required outcomes and build the project back from this point. So start with the end, what do you want to achieve, and then come back. So one great example could be, if we look at one of the typical reasons why somebody might involve themselves in a continuous improvement process. We've had it before. They say, oh, right, we want to improve margin. Well, that's far too vague. I mean, improving margin is something we'd all like to achieve, but improving margin is a byproduct of other activities. It's not the activity itself. So the idea here is the goal of the project should be, and I've given an example here, we want to remain competitive in the market and potentially go into new markets. So what I would do then, if I was on that continuous improvement project team, is I'll be saying, right, so where is our margin today and where do we need our margin to be to achieve that target? Now we've got a number, a single point that we can hang our hats on and say, that's what we're driving towards. You know, if the other part of that goal is to say, well, we need to reduce our costs because we can't get into certain new markets, the market price is too low for our current operating cost, then again, that serves as a single target. We know that our cost currently resides at position 1, we need to get it to position 2. So right, we now know what we need to do. So what you can do quite simply is then design a continuous improvement project plan to achieve the above targets and margins and prices that you need to achieve as a business. Another one might be to improve machine efficiencies. So very common, every production facility around the world would have been doing this for many years. But the question has to be, why are we doing this? You know, if we're just there with an open-ended, we need to improve efficiencies, that doesn't give the focus to the project that you need. It doesn't give you a beginning, middle, and end of that continuous improvement project. Excuse me. So a particular goal, if you were to set yourself a goal in this sense, would be to release capacity due to operational constraints and increasing lead times. The business has got a problem due to increasing lead times. We want to do a continuous improvement project in order to improve the situation and reduce our lead times to our customers. So again, the approach would be, what is the capacity gap in kilos, minutes, or hours, depending on how you're measuring your machine speed and your utilization. And then again, design a CI plan to achieve that. And I'll go through the other two a little bit quicker now. I think you're kind of getting the idea. If you wanted to reduce your CO2 impact for extended producer responsibility, again, to just have an overarching, we want to reduce our CO2 impact, it doesn't give your project a beginning, middle and end, which it's strange for me to say it's continuous improvement. So should a project have an end? But it does. I mean, you can then launch the next project at the end. But for an extended producer responsibility and for customer perception, CO2e needs reducing. That gives a goal to that particular project. So again, where are we today? Where do we want to be? Set a target for that and design all of your projects to do with that CI project around achieving that specific goal. And then reduce waste. Everyone wants to reduce waste, but there has to be a why. In this instance, I've said, customer rejects are increasing, it's putting a strain on the production team and raising a concern about business retention. And then you can see the approach there that I've proposed. It might just seem like words on a piece of paper, but the importance of setting these goals in a CI project, beginning with the end in mind, without these things, you end up with a project that could go anywhere. And that lack of focus and that breadth of activity often leads to failure in achieving the goals that you're looking to achieve. And it's really, really interesting where life cycle assessment is one of my newer skills, where I'm working with PhD level graduates that are supporting me in some of these activities that the business is running. The specific unit, the project brief, what are we looking to achieve? Nothing starts in a life cycle assessment without those things identified. Life cycle assessment is a remarkably broad field. CO2e is one measure of about 11 or 12 key measures that you can environmentally assess your business against. At the moment, carbon footprint is deemed to be the biggest planetary issue today, so that tends to be the big focus, and most environmental assessments done are centered around the CO2e functional unit, but there are other functional units that you can use. So yeah, again, the project brief, begin with the end in mind. It's just absolutely critical. So we get to the data gather stage. So this will be the area where I think most people on the call and watching the video will be probably most comfortable with. So difficult decisions are made easy with good data, something I've been saying, and I'm sure all of you guys have been proving for many years, given that we're all cost engineers. So gather data to ensure all elements of the project are clearly investigated. So the idea here is give yourself a complete data picture on the area that you're looking to assess. So, with cost modeling, it's much easier to assess this. If you're talking again about that salad pack, I need to understand what my raw materials are and what the cost of them are and how much I needed to use to produce a typical order quantity. What's the production equipment that went into producing that, print, lasering and slitting. So I need to know what the inks are doing, what's the supply chain doing as well in terms of the packing, delivery and storage. You need to gather all that data and you need to put it all into one place. And then potentially you might then end up needing to build a model. But we need to make sure things like the data is gathered in a consistent way. I've mentioned already, particularly for life cycle assessment, that's critical. But let's be honest, for cost, that's also important. And that consistency in that data is important because where you might then want to do mathematical modeling thereafter, in order to model the scenarios that you want to consider for part of your continuous improvement project, these need to be, when you then remodel the solution afterwards, you can then see a pretty good accurate impact of what those initiatives should deliver. Convert data to a consistent unit of measure. Now, for cost engineers, this seems pretty straightforward. I'm quite sure you guys have seen all the same things that I have. Some of these Excel spreadsheets that find their ways around the businesses that we work with, units of measure, that mathematical process, we see done often wrong, and often the simple unit of measure calculations like weight or area, these are fine. It's some other things that we see that people get wrong, and the net result when you get a unit of measure conversion wrong, the net result on the final results can be quite significant actually. So At this stage as well, in the continuous improvement project, we would suggest building any bespoke models required to calculate the existing cost or impact today, ensuring that this is repeatable for alternative scenarios for the project brief. So we would recommend looking for third-party solutions in this case. So you might be working for an automotive company and you might be doing a CI project. These guys invented the continuous improvement, a lot of the principles and practices that go around that. Now, the principles and practices aside, when you want to model the impact, having a good, clean, accurate model that you can then change parameters and see the net effect, these can really take some months to develop, even sometimes years. If you really look at benchmarks, been running 11 years, we're still playing with our cost model and improving it and upgrading it for the packaging industry. But you know, there might be a case that you've got a core model, but you need to build supplementary models to support that. This is the stage that you need to do that, to make sure that really the models are working, stress test those models, make sure they're correct, and it really proves that you've got all the detail and the data together. If it can't be monitored, it can't be improved. You know, that's rule one in lean manufacturing. You know, you need to make sure you get these models built such that you can then model the impact of these things thereafter. So the other thing to say as well, and it's just kind of a side point with the data gather stage, which is only to say that, you know, as you start gathering data in the business, and we do this ourselves when we do CI projects on behalf of our clients, you might find that if there's 5 manufacturing plants in the group, one site is really good at gathering data on an operational side. Maybe they invested in some software, another site is, and a lot of it's still done manually, written down pieces of paper. You know, we strongly recommend that you know, you can take this as an opportunity in the project to really go to the business and standardize to a best practice approach to gather data in a consistent way, because the one thing that's clear, particularly with carbon footprint and the modeling to net zero, is that you might and you will put together a plan which maps out your carbon journey down to a net zero position, and it might take you 5, probably more like 10 years to get there. So what you'll need to do to your senior leadership team, of course, is report back year on year, are you achieving that goal? And the only way really that you can report on that is by having a really strong model at the beginning to say, this is where we are today, this is where the business is today, and based on the modeling, if we do these activities, we should see that slowly come down point by point. And then you can then use that model to prove that actually the net effect of your activities is driving that benefit, and then report that to your customers as well. So really critical that, you know, a robust mathematical model will enable the following project phases to be a lot easier, a lot cleaner, and a lot more easy to manage. So the project scoping phase, this is where we're starting to focus the attention on areas of the business where we hope to make a big impact and really go a long way to achieving whatever goals that you set out in the project brief stage. So analyze the data model developed and identify key cost or CO2e drivers depending on the project brief. So, you know, if I look at my cost drivers on the left-hand side, if cost was part of my agenda, clearly here, the big cost drivers are to do with process 2, which in this case is print, and the raw materials themselves. And actually on the right-hand side, we're looking at the raw materials again, not surprisingly, and actually the print process as well for the paper solution. So immediately by having the data, understanding it, we can immediately, if it's a cost-based activity, start focusing our attentions really where we can have a big impact. You know, conversely, it would not serve us very well to get involved in a continuous improvement activity on packing and storage, because the packing and storage really doesn't carry a lot of weight in these particular packaging items. So, you know, we can make a huge amount of effort here and not make a big impact. Similarly, with carbon footprint, and it's almost always the case, raw materials play a huge part. So really, if we wanted to reduce our carbon footprint, we need to think about what we're doing with the packaging specification. And also, I can tell you, just from my side, the end of life journey on that as well. If we can close loop recycle this, it makes a huge impact on the life cycle assessment of the product. If we do it scope 3, right cradle to grave. So ultimately what we need to do is off of the data process, which is the previous slide, and then building the models and making sure we've got good visibility of what we're looking at here and how the data is built up, hopefully we can find ourselves in this position that we're looking at here, where we can say, right, well, you know, maybe we want to move to the paper solution because it does drive a great, you know, consumer perception, but this is the position we're finding ourselves in. So, you know, maybe cost isn't part of this discussion, but we say, well, look, is there a paper solution? Is there an end of life solution? Is there a closed loop solution that actually we can go for this lovely looking paper pack that we see on the right hand side, albeit we can get that CO2e number down because we're going to supplement that or complement that with something else that we're doing in the supply chain. That would be the right conversation to have as a result of this data that we're looking at here. But because we've got good data, we can have that conversation. You know, these guys have launched this product for the Crudits there. In the paper solution, they've clearly not had that discussion, and they've not organized their project in this way. But the one of the things I would strongly recommend you do as well is back calculate what the key costs and CO2e of these key drivers would need to be in order to achieve your overall goal. So let's say that this is a cost focused activity. Let's say that we're looking at this plastic pack, and let's also assume that that is costing us 20 pence per square meter as a cost of a product. Now, we might say that our margins are just not good enough at that price. So we need to reduce that to 18 pence a square meter by 10%, because that would then hit our group margin targets for this, you know, really important key product area. So now we've got ourselves a target. We've got 10% and 2 pence a square meter. That's what we need to achieve. Now we can start looking at our key cost drivers and saying, right, where are the big costs? Where am I going to start investigating to take out my 10% cost? Well, again, packing, delivery and storage, you'd need to make a huge amount of effort there. And even if you did, you're unlikely to find your 10%. So we know we need to be focusing on the print process and probably raw materials as well. We also have a reasonable amount of cost in the printing plates as well. It's higher than I'd usually expect to see. Maybe there's something we could do to inks that might claw back 1 or 2% there as well. But again, that's quite a small slice of the pie. But the nice thing is, if you were to model these things, so like take inks, for example, you might say, well, you know, even with our best efforts, there is no way we're going to get anywhere near 10% with our overall 10% saving by playing with inks, which looks to be only, you know, 10% itself to do with the overall cost. So what you can start doing is modeling, well, how much does print, how much does raw materials need to reduce in order for us to hit that target, and back calculate that. You can then design your project work around hitting those specific cost targets. And that gives you a much clearer project goal. You're starting to really start refining down now what are the specific numbers you need to achieve and how you're going to achieve them. That's the critical point. The other thing to say as well is, and this is the takeaway for the slide, forget preconceived ideas and allow the data to guide the project. Again, you know, having been part of some of these projects before, you do find people coming in and you know, I always respect experience and we always have to be careful not to ignore that. But preconceived ideas can often pollute an otherwise, you know, good discussion that says, well, you know, the production manager says we need to do X. This has always been the problem, and this is where we need to focus our attention. It's the setup time on the print machine. Well, it might be the case actually that the waste is the issue on the print machine, because we could go another level deeper on our data and look at where the cost on print is coming from. So, you know, we need to allow the data to guide the project rather than you know, somebody coming in and just using their supposed experience in order to say where the project focus needs to be. Allow the data to tell that story, and look, 9 times out of 10 it's likely to be that the production manager is probably correct anyway. So right, the final stage of the process is then to run the analysis. So once the key cost and CO2e drivers have been identified and improvements to these areas have been mathematically calculated, we then need to bring together our cross-functional team in order for those ideas and strategies to be built. Now, obviously, it's so much cheaper to run that analysis that we discussed in the previous slide and come up with those ideas and rerun those through the model. Then a lot of people don't do that. And then they'll step immediately into running the project work and not actually looking at the numbers. You might actually come out with, well, you know, we set ourselves a target of halving the setup time on the lamination machines or something like this. You might then very well achieve that target and you might do a really good job, but the net effect on your overall price isn't that which you need it to be in order to hit those target prices that you needed to hit. So run the numbers first. It might save yourself a lot of work working on a particular solution, a particular project that actually is not going to achieve your goals in the end anyway. So again, run the numbers first. It costs nothing, or a lot less, I should say, than actually you know, the amount of time, effort, and money that it takes to run these projects at the beginning. So that's that second point there. Ultimately, you should challenge your project team to answer the question, will these ideas and concepts proposed deliver the model benefits? So once you've actually run those models and, you know, there's a sense check at the end to say, you know, if we were to work on the setup time on the printing press, or, you know, reduction on number of inks, or the ink cost itself, if we were to run these different activities, we add those all together, do we believe that those concepts are going to deliver those numbers in the end? And you should try and do that with the smallest number of concepts available. You might, during this continuous improvement project, and this always happens, when you really block your diary out and you sit and talk about those creative things that you can do as a team to try and drive improvement through the business, be it reduce cost, reduce CO2e, improve waste, or, you know, improve speeds, the whole raft of ideas can come from the team. It's just great that you've facilitated the team sitting around talking about these things. The issue is you can end up with too many ideas, and it might be tempting just to say, right, well, let's do all of those ideas because they all sound great and they all make sense and we should be doing all of those things. When instead of 10%, who knows, we might be able to achieve 15, 20% if we do all of these ideas. The issue you've got here is that you can confuse the project. You can get it going in too many directions. What I would say is begin with the end in mind. So if you found what you believe is the solution to 10%, stick with your 10%. Don't try and go for 15 or 20, because then you're going to try and make the project too big, too broad, and then there's a risk that you might not deliver those goals that you were hoping to deliver. So by this stage, prior to implementation, the project team should be clear on what you aim to achieve, how you will achieve it now, and why it is important. You know, we want to achieve that 10% saving because we want to protect the business in the fresh produce market, because you know, we're struggling to achieve our margin targets, and you know, we want to make sure it's sustainable. Might also, as I mentioned, be that you want to you know, what you aim to achieve is getting into a new market, and you need to reduce those costs in order to be able to compete with the market price in that new market. So how will you achieve that? Well, you know, that would have all been laid out. And then why is it important? Well, we want to go into the new market, so that's become a business goal. So hopefully you understand, by taking, you know, a data analyst's view on a continuous improvement project before launching any projects, any mini projects, cross-functional teams, you know, do the project brief, understand why you're doing what you're doing. So when you get presented with all that data and you do your data gathering section, you know what you're looking for, and you can, you know, really go from that broad data set down to something that's a lot more focused and refined. We then put together, once we understand what we're looking at, we've got the data, we've built the models, we're then looking at you know, which specific areas we need to look into then in order to be able to drive and achieve the goal that we set out in the project brief. We can then start putting together those project ideas that say, right, what are the specific activities we're going to do? Then, just before you launch any of those projects, run the analysis on those key ideas. Make sure that they are actually going to deliver for you the benefit that you hope that they're going to deliver to achieve whatever goal that you've got. And now, if all of that makes sense and everything looks good, then we get our cross-functional team together, we launch the project, and hopefully have a success. But at least you're doing that with an eyes wide open, and you've done everything you can at the beginning to make sure that you're directing and driving the business in a direction which will achieve whatever goals you set yourself. A lot of these projects do get lost, and they always will end up delivering something, in terms of benefit. Continuous improvement projects often always do, but really, did it deliver the original goal? You know, you've got the business all excited and a whole team of people excited about moving forward in a certain direction. It should be with a goal, not just because, you know, we need to increase speeds or reduce waste. It's not enough. It doesn't direct a project or a business. So with all that, and hopefully, you know, understanding all this to do with project management, the life cycle assessment part at the beginning of the presentation, where I just very quickly went over some of the key principles and data sources and things like this on life cycle assessment. Hopefully you understand the importance of that, and the reason why I went over some of those that information again from the last presentation is because if you are putting a continuous improvement project together and it is within the life cycle assessment boundaries, then you really need to be clearly defining what are your data sources, where are they coming from. They need to be consistent, and ultimately underpinning everything, particularly if it's in Europe, you need to make sure that you understand your anti-greenwashing claims, to make sure you're not giving data back to your business that they're then publishing, and then you could potentially getting your business into trouble for those countries that have green claims codes like the UK. That's the presentation. If you have any questions to do with you know, how you go about setting up a continuous improvement project, we do have tie-ups, and maybe Jerry, you might want to jump in and say a word to the Society of Value Engineers.
Sure.
But other than that, that's how I would and do as a business link you know, continuous improvement to both carbon footprint modeling and cost modeling, and how that whole thing ties up together. Any questions about specific projects that you've worked on, you'd be welcome to ask.
Yeah, so Gary, sorry to interrupt. I have a question for Liam. It's not so much a question, but can you take a minute or two and explain what sets Benchmark apart from some of your competitors?
In terms of cost and carbon modeling, we are pretty much the only company that I'm aware of that does both. So if you did want to understand what the commercial implications are for reducing your carbon footprint, or if you want to know what your carbon footprint implication is for anything you change on the commercial side, we can provide that assessment. Otherwise, as cost modelers, we are quite unique in the packaging industry. Nobody really does what we do specifically in the packaging industry quite to the level of detail that we do it. We've got a pretty remarkable database of live users that use our system daily in pricing. So you know, that supports the business on the should cost modeling side as well. That gives us a unique insight as to how packaging is produced. So yeah, that's the short answer for where Benchmark's quite unique, both cost modeling and estimating.
So Jerry, I do have a question for Liam. You can hear me?
Yeah, go ahead, Gary.
Yeah. Let me preface it. I often do presentations at conferences, and typically at the end of my presentation, I'll go to the door as the people are leaving, and they'll nod to me and they'll say, very interesting. And I'll say, interesting or relevant? There's a difference. And I thought your presentation here was relevant in the context. Okay, so the question is, what has been a major lesson learned by your customers that have implemented some of the methods that you've described today? What's been a major lesson that they have learned in the experience?
Failure reduction really is the key lesson. The environmental social goals in the UK and Europe are changing very fast, and to try and keep up with it is very difficult. Brand owners and retailers in the UK in particular are falling over themselves to try and subscribe to the newest concept, or you know, Loop was a great one, which has since failed, unfortunately. You know, that instead of having specifically packaged things, you can have dispensing units for dry and wet foods in the supermarkets. Again, this didn't work for a whole variety of reasons. I think this is about planning. This is about running data models before running projects to see if they'll work. And I think for us, the mathematicians, the Society of Cost Engineers, it's a lot easier to run numbers than it is to run a project. So run the numbers first. It reduces your failure rate. And people are running at the moment in Europe to try and do the next thing, to try and give the message to the consumers that they're doing something that's really environmentally friendly, which is great. And we need to do more of that type of thing. But there's a lot of energy going into failed projects at the moment. That's the absolute truth of it. And I think if you stop and think and you run the numbers first rather than running the project first, some of this stuff could have been avoided. And actually, maybe we could have put that project aside and focused on something that really could have made an impact. So at the moment, I'm seeing, I don't know, 3 projects in every 10 being a success. And even the ones that are perceived to be a success will run the numbers on, and actually they've chosen something that isn't as carbon effective, isn't as good for the environment as the plastic solution they had in the beginning. And that's one of the big problems we've got in Europe at the moment, the rush towards paper. In some instances it's fine and it does work, in others it doesn't, but just to have a blanket approach. So again, run the numbers first. I think the one learning is reduction in failure is what you'll achieve if you build these models and run the numbers first.
My next question is the adoption rate for those that haven't even got started, whether they were successful or failed, as you just described, but for those who have not even begun the journey, what has been an obstacle or barrier that is slowing the adoption rate? I think we all, especially our kids and our grandkids in the future, would like this climate change thing to be addressed. What has been what are the barriers or obstacles slowing the adoption rate for organizations that have just really sat on their heels and not proceeded?
Well, specifically on the, I mean, it's not to do with continuous improvement, I guess it kind of is, but I think for organizations, the issue is lack of guidance and consistent guidance from governments. If you look at the big brand owners that we work with, they can't make one decision globally because each individual country is making decisions locally. So businesses end up doing a huge amount of research, trying to do life cycle assessments and things like this. And then, you know, it's difficult to pick a path, and the legislation changes, the guidance changes, and then we all, you know, we're suggested to do something else. So it's intensely difficult for big brand owners to really put a plan together and stick to it if the rules around them keep on changing. You know, you might take a simple example. If you look at recycling, you might choose to specify your packaging such that it's recyclable, but then not a lot of materials in some countries in Europe are actually recycled today. So you might take a view that says, well, if I make it recyclable, well, then the infrastructure in those countries, it's their job to catch up. Another organization might say, well, no, if it's not being recycled today, we want to take the responsible decision and choose something that will be. Well, it might be the case that you move to paper and you're actually increasing your carbon footprint because you want to move to something that's a heavier weight specification because you think it's going to get recycled. It's an intensely difficult thing to navigate. So I think with regards to ESG goals, that specific topic, I think the biggest challenge that the brand owners have got, which was your question, of course, why they fail, is because the rules change too quickly. The second you've put your project plan together, the rules have changed, you've got to rewrite it again. And then you end up stuck in the planning stage and getting nowhere. So I think that's the biggest challenge at the moment is inconsistent information, lack of guidance.
Well, thank you very much for a presentation that, as I said, is much more than interesting, but also relevant. I'm going to throw a curveball to Jerry. Jerry, would you like to do some concluding remarks? And we'll let our attendees get out a couple of minutes early here, then
Sure.
the full 60 minutes. So thank you very much, Jerry, for asking me to be the moderator.
Sure. Thanks, Gary, for being the moderator, and Liam, thanks for an awesome presentation. I just want to remind everybody that the Society of Cost Engineers is free basic membership. It's at www.societyofcostengineers.com. We have recently added a sister division to Society of Sustainability Engineers. You can find that at www.societyofsustainabilityengineers.com. We are going to be partnering with the Society of Value Engineers as well, hoping to offer a suite of solutions, assistance to all of the engineers, because all of these different disciplines are starting to intertwine very nicely, and like to help out wherever we can. If you've got any questions, comments, suggestions of topics for webinars, feel free to reach out to us through the Contact Me page on the website. Again, thanks, Liam. Thanks to all the attendees, and thanks, Gary, for moderating it. And I'll give you guys all about 5 minutes back to your day.
Thanks,
Everybody
Jerry.
have a good day.
Thanks, Gary.